Tempering is a heat treatment process to seek to obtain the maximum hardness of material, which is heated and then cooled. Tempering consists to modify the steel by heating it to high temperatures, generally between 750 and 1300 centigrade, to maintain its stain and then cooling, generally with oil, water, or air. They modify the structure of the steel to obtain great durability. Thanks to this process, we can obtain parts capable of resisting high-impact forces and cutting tools. The properties achieved allow greater resistance fatigue, tensile, and compressive stresses, which are necessary for the highest performance part in mechanical components and, above all, in tools.
We can identify two main stages. 1. Heating. This is the first step of the thermal process, where we will raise the temperature of the steel until the formation of austenite, the rearrangement of the iron and carbon atoms that make up the steel. It is this point of stability of the austenite when we will continue with the cooling to obtain the desired results. 2. Cooling. Once we have achieved the stability phase, the next step is the cooling of the steel. This process is carried out through a chilling medium, which can be either a quenching medium or cooling medium. The choice of the most suitable medium to continue this stage is going to depend on the composition of the material to be tempered. This is why it's normally determined through tests and analysis of the parts under specific conditions. Tempering speed is important. Higher speed will result in a martensite structure, the hardest of the austenite transformation components, while lower speed will result in a microstructure such as bainite or fine pearlite.
What is annealing? The annealing process helps materials become softer, more flexible, and less fractured under great stress. Conversely, it improves functions and strength properties, making them suitable for various industrial uses. Stage 1. Heating. In the heating state, the material is raised to between 400 and 900 centigrade. So the atoms move, dislocation decreases, and the internal stress relaxes, thus preparing for grain growth. In the recrystallization state, the material is kept hot for necessary time to form new grains further to reduce the dislocation and soften. This can take from 13 minutes to several hours depending on the material. Cooling state, the material is cooling in state usually in furnace to improve its ductility and strength. There are several types of annealing such as full annealing, recrystallization annealing, stress relief annealing, isothermal annealing, diffusion annealing.
Annealing is a heat process applied to hard steels, usually to reduce brightness and relieve stress while maintaining some hardness. Purpose and characteristics. It reduces the brightness, it also increases the toughness and ductility, sacrifices a small amount of strength, and tailors mechanical properties to the tools, springs, structural components, etc. Microstructural change. As quenched, martensite is initially hard and brittle. During tempering, excess carbon precipitates. At low tempering temperatures, formation of tempered martensite and fine ellipson carbides. At moderate, coarse carbides from lat structure relaxes. At higher, regression of martensite to ferrite plus spheroid carbides. Overall, transition from hard, stressed martensite to more ductile structure with distributed carbides.
Example of a heat treatment tempering. We will observe how a metal spoon deforms when heated. Materials: metal spoon, candle, and cold water. Procedure: heating. First step. We hold the spoon and reach it close to the tip of the candle fire. We observe how the metal eats up and becomes more malleable. Deformation. 2 step. We apply pressure on the tip of the spoon to bend it. Here we notice that it is easier to bend it when it's hot. Cooling. 3rd step. We submerge it briefly in cold water and we will see how its hardness results. By heating the metal and manipulating it and then cooling it quickly with cold water, we observe that its temperature treatment is crucial to improve the mechanical properties of metals, especially steel, making them more resistant, durable, and able to withstand demanding working conditions.